Scientists have just made a major breakthrough in improving mRNA-based medicines. Let's talk about it. Quick crash course. This is DNA. It's the master database of instructions to make all of the proteins that your cells require to function. This is mRNA. It's a single-use copy of those instructions that gets printed out whenever an order for a specific protein comes in. And this guy is a ribosome. Ribosomes are the assembly line machinery inside of your cells that actually put together those proteins according to the mRNA instructions. Now imagine if this guy had a bunch of little assistants that were standing around holding all the pieces that he needed to build a specific piece of protein furniture. He'd say, "I need a leg for this chair," and the assistant holding the leg would step forward and hand it over to him. Your ribosomes have assistants like that. They're called tRNAs. As a ribosome reads those mRNA instructions, it hollers for the next protein component that it needs, and the corresponding tRNA steps up and hands it over. Each tRNA is specific to the part that it can hold, so there's tRNAs for drawer handles, tRNAs for chair legs, etc. If you spend all day every day assembling furniture, you'll start to realize that a lot of them share the same parts, so you'll hire more assistants that are capable of holding those parts and fewer assistants that hold more unusual parts. Your cells are doing this too. Different tRNAs capable of holding different protein building blocks occur in different amounts based on demand. But that means that if an unusual order comes in, the mRNA instructions can get read on the spot, but the right tRNAs for the job might not be present to handle it. This slows down the protein assembly process, which leaves mRNA vulnerable to attack by cleanup molecules that are constantly prowling around in your cells looking to clear out any instructions that aren't being used. It's like trying to assemble IKEA furniture with a puppy in the room. If you put down those instructions to go spend 10 minutes looking for a missing part, the puppy's going to tear up the instructions and that furniture is not going to get finished. mRNA is a great option for medicines. It gives your cells a temporary set of instructions to make a helpful protein that they normally wouldn't or couldn't without altering the underlying DNA. But if cells are being asked to make a protein that they normally don't, which again is the whole point of these medicines, they might not have the right tRNAs on staff to handle the order. That's where this study comes in. Researchers found that if you deliver not just the mRNA instructions to make a protein, but also the tRNAs required to help make it, the ribosomes have a much easier time of handling the order. They also found ways to chemically enhance these tRNAs to make them better at handing over the right piece at the right moment, again resulting in more and faster protein production. When they used this strategy to deliver mRNA used in a vaccine to mice, they found that the mice had a stronger immune response and produced more antibodies to the virus, meaning that the vaccine was more effective. Now, there may be downsides to this. Having too many assistants handing you stuff too quickly may overwhelm your ability to actually work on the project in front of you. So the authors recommend further studies to determine the impact of this approach on cells' ability to make proteins overall. But either way, this represents a very cool potential shift in our strategies surrounding mRNA-based medicines. So far, a lot of the technical advancements that we've made, including a Nobel Prize-winning one, have focused on tweaking the mRNA molecule